So hello everyone, my name is Muhammad Rizman Shaban Rizal. So today I'm gonna talk to you guys how to derive the most famous equations that changed the modern physics proposed by Albert Einstein, E equal to mc square. Albert Einstein proposed these equations state that energy is equal with mass times with the speed of light, the power of 2. So how we gonna derive this and how we gonna prove this equation is a legit and real. So to derive this equation, we're gonna use the most common and the most easy way, that is the work energy equivalence, where work is equal with energy. So when we take work equation or work formula, we got work is a force times with change of displacement. So we're gonna do this. dw equal to f dot dx. So what we got here is dw is basically the same with change of energy. Change of work is basically the same of change of energy. So after this, we're gonna go to the Newton's second law of motions, state that force is a change of momentum over time. So we can see here in the picture, force is a change of momentum divided by change of time. So after that, we need to find the change of momentum. So we know the momentum formula is mass times with velocity. So we're gonna differentiate the formula so we can find the change of momentum. So we're gonna get dp equal with m dv plus v dm. After that, we find out that dp here, we can substitute this from, as you can see here, we can substitute dp here with this. So after that, we can substitute this new equation here, md and dt here we can put with dx, and we're gonna find dx over dt. So what dx over dt mean is dx over dt is a velocity. Change of displacement over change of time is velocity. So we're gonna substitute dx over dt into velocity equal with velocity. So we're gonna find, and we'll multiply this into this equation. So we're gonna get this. So we're gonna get this first equation, that is change of energy equal with mv dv plus v squared dm. So remember this equation. This equation is really important. So let's move on. So after this, we're gonna go to relativistic mass. That is Einstein proposed this equation where when a certain object travels in a certain speed below the speed of light or the speed of light itself, the mass of the object will change. It will change. So how we need to find the mass of the changed object? We use this formula where m, where this is change mass, relative mass, equal with m naught rest mass. This is a rest mass, and divided by square root 1 minus v square over c square, velocity power of 2 and speed of light power of 2. After that, we can change this form into this, so we can easy to using calculus to calculate everything. So we can change it from this into here. This is a basic calculus you need to know if you want to understand this. So we go to the next one. So here, what I do is I differentiate the relative mass perspective to the velocity with respect to the velocity. So first, we use the chain rule. This is a basic calculus technique using chain rule to differentiate it. And after that, we find this answer here. All this is the after effect of the differentiated. So here we got minus 3 over 2, right? 1. So what does this mean here? We can change from, this is from index power rule, or index power if I'm mistaken. So we can change form into into this one. If so, this power here plus this one, we will get this one. So you need to have a basic calculus knowledge if you want to understand this, because this is all calculus. So basically what we got here is I simplify this, simplify this, simplify this, and simplify this, and then I got here m. There's no 2 here because I simplify it. Okay, so let's go to the next one. Okay, here you need to understand why the m naught is missing, why the m naught is gone, and why I changed it with m. Basically here, if you notice this part here, is basically the same with this part. Yep, this part here. If you notice, that part is the same. So what we're gonna do now is change it to m, because this part is equal to m. So now we got that. So we simplify this using calculus. Simplify, you got this one. Simplify from this, you got this one. Okay, so if you want to know, here is basically this one equal with c square over c square. This is what the meaning of the one here, if you want to know more deeper, but I don't have much time, so this is a basic calculus, I guess you guys already know. So we go next, and here what we do here is, if you see here is a dm over dv, right? Is a dm over dv. So what we're gonna do here is we remove this dv to here, and we remove this c square minus v square to this side. So what we got is c square plus c square dm minus v square dm equal mv dv. So after that we're gonna move this v square, we're gonna move this v square to the other side, we're gonna move it to this side. So what we get is this new equation, mv dv plus v square dm. If you remember correctly, this equation 2 is the equation, the first equation that I gave you, the first equation that I gave you. If I'm not mistaken, it was here something. Yep, remember here, mv dv plus v square dm is equal with de. So after you look back into the latest equation here, I got we can change this part with de, because it's the same. So we change it with de. After that what we do is we differentiate de and we differentiate dm. So after that we got this change of E, change of energy, equal to change of mass times with this time with speed of light to the power of 2. So basically this is how we prove the theoretical equation that given by Albert Einstein, E equal to mc square. So if you want to know this, how I got this E equal to change of mc, is basically all calculus. What you have to do is you're gonna get E here like this, and then it's a final E and initial. Let's see, it's all calculus, and M, final and initial. So I hope you guys understand. Sorry because I cannot explain the calculus part. I can explain it, but it's just really hard to pack all the informations in one video. Overall this video only needs 6 minutes, so I hope you guys understand. Thank you for listening. I hope you guys stay healthy in this quarantine time and stay safe. Goodbye.